This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Hey everyone, and welcome to today's discussion. We're diving into a fascinating paper that challenges the conventional wisdom in large language model LLM development. The authors argue that boosting an LLM's performance at inference time, that is, when it's actually answering questions, might be even better than making the model itself bigger and more powerful during training. Sounds crazy, right? Let's see what the experts say. What's the core idea behind this research?
The core idea is simple. Instead of spending all our resources making a giant LLM during training, what if we trained a smaller, more efficient model and then gave it extra time and computing power to think through difficult questions at the moment it needs to answer them? Think of it like this. Humans don't always give instant answers, especially to hard problems. We take time to think it over. This paper explores if we can give LLMs that same ability.
So instead of a bigger brain, we give the LLM more time to think. How do they actually do that? What techniques are used?
They explore two main approaches. First, they use something called a verifier, which is like a separate little model that checks the LLM's work. The LLM tries different answers, and the verifier picks the best one. Second, they let the LLM revise its own answers. It gives an initial answer, then looks at it, and tries to improve it step by step.
Okay, so a verifier to check answers and a self-editing feature. But how do they decide how much thinking time to give the LLM? Doesn't that just use more computing power?
Exactly. That's the key. They developed a compute optimal strategy. They figured out that the best way to use extra computing power depends on how hard the question is. For easy questions, a little extra time for self-editing might be enough. For hard questions, trying many different answers and letting the verifier choose the best one is more efficient.
So it's like giving a child more time to solve a simple puzzle versus giving them a bunch of tools and letting them experiment to solve a complex one.
Clever. What were the results of this approach?
They found that their compute optimal strategy was much more efficient than just trying lots of answers at random. In some cases, they got better results with a smaller model and extra thinking time than with a much larger model that didn't get any extra time.
Wow, that's a significant finding. So, smaller models with more thinking time can sometimes outperform larger models. What are the limitations of this approach?
The main limitation is that this approach doesn't always work well on the hardest questions. For those, it seems that a larger, more powerful model is still needed. Also, figuring out how hard a question is takes some computing power itself, which needs to be considered. So it's not a complete replacement for bigger models, but a valuable addition for certain types of problems. This is a really interesting shift in how we think about LLMs. Thanks for explaining this.
It's a promising area of research, and it could lead to more efficient and effective LLMs in the future.
Absolutely. It's exciting to see this new perspective on LLM development. Thanks for joining us today.
My pleasure.
And thank you to our listeners for tuning in. We hope you found this discussion insightful.